So here uh, we have, I think I have given one example. Okay, that whenever you are providing the interrupt, first uh, we need to identify the necessity of that interrupt. Okay, why the interrupts are necessary for microcontrollers. Okay. Now here we have seen that uh, one example I have given to you, that if you are studying and during the study, if you are having if any friend of you is calling you, okay, then it depends upon you whether to accept the call or not. Okay, but before that, since there are two ways to interrupt the microcontroller, the first is by providing the interrupt, and the second way is providing the polling. Now, what is the meaning of this polling? Now, see, whenever the microcontroller is communicating with different peripherals or doing different functions, so in that cases, here the microcontroller needs to provide the service to every peripheral, okay, or needs to provide a service for every requirement, whatever given to that embedded system. Okay. Now, while that, if suppose the interrupts are not available and if we are only providing the polling status, so in this polling, what will happen? The microcontroller will continuously will keep in the loop. Okay, that means here, if suppose you are, anyone will call you at a specific time. Okay, then if you do not have any sort of work, what you will do? You will wait unless and until your phone runs. Okay, so you are waiting for that call if you do not have any another function or any another task. Okay, so here whatever the time you are having, you consuming that time only for this polling purpose only. Okay, that means only for a single call you are waiting for, or you are providing all of your time for this call only. Okay. So here the complete time will get consumed by call. Now, in the same case, if you are assume that you are studying, okay, and at the same time uh, anyone is calling you, okay, then to which function you need to do. Okay, the first is if you are waiting for this call, the complete time required for the study that will get elapsed. Okay, so you will not study unless and until this call is happened. Okay, so this is the case. Now, for that purpose, what you will do, you will give or you will put your mobile in ring mode. Okay, you will put your mode in mobile in ring mode, and you will start studying. Okay, when you get the call, the mobile will ring, and you will receive the call. That means the ringing of mobile, it is nothing but providing the interrupt. Okay. So when the interrupt occurs or when your mobile rings, you receive the call. Okay, and for that much of time, you keep aside your study, you attend the call, and after complete attending the call, again you will resume your study. Okay, so here what will happen? The complete time, whatever you are having, you are utilizing for study also and for attending the call also. Okay. Now, you take the example that during the same process, if you are watching TV, okay, then what you will do during the study, if suppose you want to watch a movie or watch a match, cricket match, okay, cricket match, okay, you want to watch this cricket match, but this cricket match is will get telecasted at a specific time. Let's say X time. Okay. Now, for the study, you are having the time from A to Z. Okay. So during this time, here you are having a time X. Okay. Now, if you are not having any interrupt, okay. So what will happen? You will wait only from A to Z. Okay. You will not wait for X. Okay. But if you are having a specific time, okay, that is provided to you, what you will do, you will provide alarm for this X. when the alarm rings, you will turn on TV and you will watch this cricket match. Okay. And during this session, if suppose the mobile rings, then what will happen? Either you will attend the call or you will watch the cricket match. That means here the priority to watch the cricket match and priority to attend the mobile, these both are having different priorities, and it depends upon you or the programmer to which you want to serve. Okay, so that all thing can be done in interrupts. Okay, so this can be done in an interrupt, but that cannot be done into the polling. So we can say that for polling, here it is time consuming because it requires continuous monitoring of that event. Okay. Second thing is that here there are no any conditions that are provided or priorities that are provided for different actions or different events. Okay. So here only the thing is that if the condition is met, then it will perform its operation. If the condition is not met, it will check or it will keep in the pooling mode unless and until the condition gets satisfied. Okay. And we can give an example for this here. We have done the programmer for timers. Okay. So here what we have written, we have kept the program in loop mode unless and until this TF bit is set. So unless and until this TF bit is clear, we are keeping it in the loop mode. And once the TF is set, we are exiting from the loop. And we are doing, or simply what we have done, we have inverted the pin status. That means from 1 to 0 or from 0 to 1. Okay. So during this case, here what we are doing, the microcontroller is only checking the status of TF0. Okay. So all the time is getting consumed for checking the status of TF0. Okay. So in spite of that, one more function which is available with the interrupt, with the microcontroller, that is the interrupt. So here what will happen? Once the interrupt signal is generated, then and then only that specific interrupt will get served. Otherwise, the microcontroller will do its own operation. Okay, whatever it may be. Okay. Then, what the microcontroller will do, when the signal is received from the interrupt, the microcontroller will keep its current execution. It will execute the current instruction, and the address of the next instruction will get stored on the stack. Okay. After that, what will happen? The microcontroller will switch to the ISR location, that is called as interrupt subroutine. Okay. This is also the same as that of subroutines which we are written for software programming. Okay. But these specific subroutines are written for interrupt only. That's why it is called as interrupt subroutine. So the program counter will get loaded with this interrupt ISR address, and after that the microcontroller will serve that ISR, and again it will return back to the main program. Sorry. So here we can see what the difference in between the interrupt and polling. So polling method is not efficient. Why the polling method is not efficient? Because it is time consuming, and every what we can say, it is the continuous process. Okay, and about the interrupts, here the interrupts are getting served only if the signal is generated, or if only interrupt is generated. Sorry. So otherwise the microcontroller will do other functions. Okay. Now here in this interrupt, if suppose the microcontroller is communicating with different peripherals, okay, then to which peripheral the microprocessor will provide the service first, and to which peripheral the microcontroller will provide the service later, that will get decided into the interrupts by assigning the priority. Okay. So I have given one example also. If you are watching the cricket match and if the mobile rings, okay, now watching the cricket match, it is one interrupt, and attending the mobile or attending the call is another interrupt. Okay. So the programmer, or you can say the owner, what will do? Either it will provide the most priority to watching the cricket match or to attending the call. Okay. So if the most priority is provided to the watching cricket match, then the person, what he will do, he will just discard the call. And if the mobile call is having the highest priority, then during watching cricket match also, if the mobile rings, then that particular task or attending the call will be done first, and after that, watching the cricket match will be done. Okay, so here the priority assignment can be done into the interrupts, not into the polling method. Okay, so so these are the differences in between the interrupt and polling method. Okay. One more thing is that in this interrupts here we can mask the interrupt. Okay, already in the last lecture I have seen the types of interrupts. Okay, so here we have seen first the interrupts are divided into vectored interrupts and non-vectored interrupts. Then we have seen the interrupts are software interrupts and hardware interrupts, and also we have seen the types of interrupts as masked interrupts and non-masked interrupts. So masked interrupt means here the programmer can ignore the interrupts though the interrupt has been generated. Okay, so the facility is provided either to ignore the interrupt or to serve the interrupt. That is called as masking of the interrupt. Okay, so that can be done into the interrupts, but for the polling method that cannot be done because there is no any priority as well as there is no any masking of the devices or masking of the peripherals is done into the polling method. Now already we have seen these different steps while the interrupts are getting executed. So first what will happen when the interrupts are getting generated, then the microcontroller or the program counter will first will complete its current execution. That means current instruction will get executed first. Okay, and after execution of current instruction, here the address of the next instruction that will get stored on the stack. Okay, that means here the pushing of the program counter is done on the stack. Okay, and at the same time it will also store the PSW status, that means the different flag status on the stack. So first this PSW will get stored on the stack. After that the program counter address will get stored on the stack. Okay, then after that here what will happen, the program counter will jump to the fixed location in the memory. So what does it mean? It gets jumped to the vectored location which is provided for that particular interrupt. Okay, so here the vectored location means here the address of that particular ISR is provided into the memory. Okay, so and we can identify this address from the vector table which is provided with the datasheet or the manual of that microcontroller. So the program counter will jump to that specific address location or vector address location where the ISR is available. Okay, after that the microcontroller will serve that ISR and then it will return back to the main program. Okay, that means it will again retrieve the data from the push, okay, or from the stack. So here when the ISR is getting executed, so after execution of this ISR, the last instruction in the ISR is RETI, that is return from interrupt. Basically ISR, it is the subroutine, and while returning from the subroutine, the last instruction is always the return instruction. But these subroutines are available for the interrupts. That's why it's called as ISR. And while returning from that ISR, here the instruction is available, that is return from interrupt. That's why it is written as RETI. So when microcontroller returns from the interrupt, at the time, here what will happen? Again, the program counter will get loaded with the address which is stored on the stack, and at the same time, the PSW will again get loaded with the different flag status which is stored on the stack. Okay, so this is the execution of program with interrupt and without interrupt. So without interrupt, what will happen? Here, see here, this is the main program. Here from this time or from the initial level, here the program will get executed up to this much of time. and again it will keep in the loop here like this. Okay, unless and until the event has been triggered or event has been generated into this main program. Okay, that means event means the data from the IO devices which are interfaced to the microcontroller. So here, if suppose that data is received or if this event has been generated, then that particular event will get served by the microcontroller. Okay. Now see here, if this microcontroller is doing different tasks, let's say task 1, task 2 and task 3, and these tasks are sequential tasks. That means first microcontroller will execute task 1, then task 2, then task 3. Okay. Now in loop mode, if suppose the microcontroller is executing task 2 and if the event is generated into the task 1, then what will happen? Here, that particular event will get served after complete execution of task 2, task 3, and again when microcontroller returns back to the task 1. So after that case, here this particular event, whatever has been generated, that will get served into the polling method. Okay. Now in interrupt method, what will happen? So from here from the starting location, when the execution of the program gets started, okay, during that case, if suppose the interrupt has been generated, then this program will get skipped here. The microcontroller will get shifted to the ISR. It will execute the ISR, and again it will return back to the main program. Okay. Again, during the execution, if suppose the second interrupt has been generated, again that will get executed, or the microcontroller will get shifted to the ISR, and again it will turn back to the main program. Okay. Again, for the third time, if suppose the interrupt has been generated, it will shift to that ISR, and again it will return back to the main program. Okay. Now we will take the same problem here, okay, or same task here. So microcontroller is executing task 1, task 2, and task 3 sequentially. That means task 1 will get executed first, after that task 2 will get executed, after that task 3 will get executed. Okay. Now we will take the same status if suppose the microcontroller is executing the second task and the event has been occurred into the task 1. Okay. So here if suppose any event has been occurred, okay, and that event is triggered or generated by providing the interrupt, or that signal is provided by the interrupt, then what the microcontroller will do? Microcontroller will stop its operation here. It will get shifted to the event, or it will serve the ISR here, and after serving the ISR, again it will return back to the second task, and again after second task it will execute the third task. Okay, now during this case, if suppose if any other interrupt has been generated, then also the microcontroller will do the same function. So here the time consumption will get reduced due to these interrupts. Okay, have you understood it? What is the difference between Keval? What is problem? Keval? Now am I audible? Keval? Are you there? Other people? Priyanka? Prathamesh? Am I audible to everyone?
Audible, sir.
Keval? Where is Keval? अरे झोपलाय का तू?
Audible, sir.
Okay. So in that way, the microcontroller will execute the different interrupts. Okay. Now for these interrupts, here we have seen that there are 6 interrupts. I think in the last lecture also we have seen it. The first interrupt, which is having the most priority, it is the reset interrupt. It is non-maskable interrupt. Okay. So here in some books it is written that reset is not an interrupt. Okay, but in some books the reset is treated as the interrupt. Okay. So, but by default the reset is the interrupt, and which is non-maskable. So when the interrupt has been generated from this interrupt, the microcontroller have to have served this reset. After that, there are 2 interrupts from timer, that is timer 0 and timer 1. So there are two interrupts. One is timer 0 interrupt and another one is timer 1 interrupt. These are internal interrupts, okay, which are generated from the module or the inbuilt peripherals of that particular microcontroller. So these two interrupts are timer 0 interrupt and timer 1 interrupt. Okay. We have seen the function of this timer 0 and timer 1 interrupt in timer programming also. Okay. After that, we have two external hardware interrupt, okay, which are triggered externally to the external pin. These are INT 0 interrupt and INT 1 interrupt. Okay. So these two are external interrupts which are at port 3.2 and port 3.3. That means at port 3.2, it has the INT 0 interrupt, and at port 3.3, it has INT 1 interrupt. These are external hardware interrupt. What does it mean? Here, these interrupts are occurred at the external pins of microcontroller. That is the pin number port 3.2 and port 3.3. Okay, so if the event is generated or if the signal is generated at that particular pin, port pin, then the external interrupts are getting generated. Okay. Then one more interrupt is available, which is called as serial communication interrupt. So for data transmission as well as for data reception, for both the cases here, only we have a single interrupt, that is serial communication interrupt. Okay, everyone understood? So there are 6 interrupts. The first one is reset interrupt. After that, 2 interrupts are timer interrupts, timer 0, 1 interrupt and timer 1 interrupt. Then 2 external hardware interrupts, that is INT 0 interrupt and INT 1 interrupt, and 1 serial communication interrupt, that is SR interrupt, or we can call it as serial communication interrupt. Okay. Now, see here, we can see how the interrupts are generated into that particular cases. Okay. So here, by default, reset interrupt is generated when any reset switch is pressed, or if there is any power fluctuation. Okay, in that case, reset interrupt has been generated. Now, for timer interrupts, these two, timer 0 and timer 1, these two interrupts are generated when the overflow occurs of the timer registers. Which register? The counting register or count register. When the overflow occurs into this count register, here what will happen? The TF bit, that is for timer 0 it is TF 0 bit, and for timer 1 it is TF 1 bit. Okay. So when the register count is overflow, at the time the interrupt is generated for these timer interrupts. Okay. For serial communication interrupt, when the interrupt will get generated? When the complete reception of the data or the transmission of the data is over. So after completion of the reception or completion of this transmission, here this interrupt will get generated. Okay. And these two interrupts, external interrupts, INT 0 and INT 1, these are generated when the external event is occurred at port 3.2 and port 3.3. So if the event is generated here, what is the meaning of event here? Here either change of the status of the pin. That means from 1 to 0 or 0 to 1. Okay. So if the status change has been occurred at this port 3.2 or 3.3, so depending upon that, here the interrupt will get generated. Okay. So if these two are high level interrupt, then what will happen? If the status is 1, then the interrupt will get generated. If these two are low level interrupts, then when the status is 0 at that time, the interrupt will get generated. Okay. Now here we can configure the interrupts for timers, timer 0 and timer 1. Okay. And at the same time, we can configure the interrupts for the reception and transmission of data. So here the configuration of the generation of interrupts will be done by the programmer in these upper 3, that is for timer interrupts and for serial communication interrupt. But for the external event interrupt, that cannot be configured, that will get generated when the event externally occurs at that particular port pin. Okay. Everyone understood it? So the programmer can define or configure when the interrupt will get generated for timers and serial communication only, not for external interrupts. Okay. Now we will see the vector tables of the interrupts. Okay. Now see here, already we have seen that when there are six interrupts, in which the first interrupt, which is not mentioned here, it is the reset. Okay, so when the reset interrupt is generated, the program counter gets shifted to the by default address as 0000 location. That means the first location of the memory. Okay. Now, for different interrupts here, different vector address locations are provided. So for external zero, that is int zero interrupt, it is also called as int zero interrupt. For this int zero, the vector address is 0003. Okay. Then for timer zero, here the address location is 000b. Then for just right here we will write that timer zero. Then the next external interrupt is int1 interrupt, that is external one interrupt. Then this address location for this is 0013. Then after that, the timer interrupt, we will write it as T1 interrupt. So for this timer 1 interrupt, the address location is 001B. And for serial communication interrupt, the address location is 0003. So what does it mean? If suppose the external zero interrupt has been occurred or int zero interrupt has been occurred, then by default the program counter will get shifted or will get jumped to the 0003 location. If suppose timer zero interrupt has been generated, at the time the program counter will jump to the 000B location. If int1 is generated, then at the time it will get shifted to the 0013 location. Okay. So by default here, for every interrupt there is a space of 8 bits, 8 bytes are provided. Okay. So for in between every interrupt, okay, that means from 0003 to 000B we have a space of 8 bytes. That means the ISR of this int0 is written into this space. So this much of space is provided for the ISR. Okay. Then for timer 0, here from 000B to 0013, so these 8 bytes are provided for ISR of this timer 0. Similarly for int1, here 8 bytes, for timer 1 8 bytes, and for serial port interrupt 8 bytes are provided for every interrupt. Now there are two cases here. If suppose the ISR is written for timer 0, okay, let's assume it. For timer 0, if the ISR is available here and this ISR is not sufficient, that means if suppose we are writing any subroutine which requires space more than 8 bytes. So for if suppose for timer 0, the ISR requires the space of, let's assume 16 bytes. Okay. Now here by default the space provided here is 8 bytes. Now in that case, here what the programmer will do? Programmer will write a short jump here or long jump, and will jump to the new address location. It will jump to the new address location, and to this new address location here the ISR is written. And from this ISR again it will return back to the this vectored location, and from this vectored location it will get shifted to the main program. Okay. So but by default when the interrupt has been generated or timer 0 interrupt has been generated, then the program counter will get shifted to the 000B only, and the programmer needs to jump from this location to the new address location if the ISR requires more space than 8 bytes. Okay. I'm saying bytes, not bits. Okay. So here it will jump to this new address location. After execution of this ISR, again it will return back to the vector location, and from vector location it will return back to the main program. Okay. So in this way, here the ISR are written. Okay. Now one more thing, while writing any practical program, okay, or whatever we need to burn into the main program. So here what we need to do, we need to skip these spaces which are provided for this vector location. That means whenever we are writing the program for kill, we are starting the program from 000H. Okay. But practically, when we are writing the program for any particular embedded application, then at this location, here what we need to do, we need to provide L jump or short jump, and we need to provide the next address location where all this reserved portion of this vector location will get skipped. Okay, let's assume 0100H and so on. So from this initial location, we need to jump to this 0100 location or next location where the scratch pad is available. And then we need to write the program while writing the program for any practical embedded system design. Okay, everyone understood it? So for kill, here we are writing the program with the initiation of 000H, but practically it will not be possible because if suppose the interrupt will get generated, here the ISRs are available at this specific location, vector locations. Okay. Everyone understood it? Okay, now the next thing is the control word registers which are important for interrupts. Okay, so here the first register required is TCON. Okay, why TCON is required? Because TCON holds the bits for timer interrupts. Okay, similarly SCON for serial communication interrupt. Okay, then for external interrupt, we have two more registers. One is IE, that is for external interrupts, and IP to set the priority of the register. Okay. So here this IE register will decide whether the particular interrupts will get enabled or disabled. That means masking of the interrupt can be done by this IE register, and IP register will set the priority. That means priority means either watching the movie or attending the call. Okay. To whom the first priority is provided, or to which interrupt the first priority is provided, that will get decided by this IP register. Now, whatever I am saying now, that depends upon the default priority provided by the microcontroller, and if suppose the programmer wants to change that priority or reset the priority, then this IP register is used. Okay. So by default, here the priorities are set as the external interrupt IT0 is having the most priority, then timer 0, then IT1, then timer 1, and after that the serial interrupt. Okay, so this is the basic priority which is provided for the interrupts. Okay, so first one is IT0, then timer 0, then IT1, timer 1, and after last one is the serial communication interrupt. Okay, so this is the by default priority which is provided by the microcontroller. But if suppose the programmer wants to change this priority, that means if suppose the programmer wants the priority for timer 0 first, then IT0, then that will be set by this IP register. Okay. Now we will see how the interrupts are getting enabled and disabled. Okay, so that will be done by this IE register. So here in this IE register, this D7th bit is EA bit. It is called as global enable bit. Okay. Or it is also called as enable all bit. So if this bit is 1, then all the interrupts are enabled. If this bit is 0, all the interrupts are disabled. Then the D6 bit, this bit is reserved bit. Okay, this is not used for timer, 8051. So this bit, then this D5th bit, this is also called as 82 bit. Okay, and this 82 bit is available for 8052, not for 8051. So for 8052, it is the used for enabling the timer 2. Okay, but But for 8051, here this bit is not used, or this bit is reserved. We can call it as reserve bit. Okay. After that, the next bit is ES bit, that is called as serial port in a interrupt bit. Okay. That means here, if this bit is 1, then the serial interrupt is enabled. If it is 0, then the serial interrupt is disabled. Okay. The next bit is ET1 bit. It is for timer 1 interrupt control bit. So if this bit is 1, the timer 1 is enabled. If this bit is 0, then the timer 1 interrupt is disabled. Okay. Similarly, this bit is X1 bit is for external interrupt 1, IT1 bit. Then ET0 it is for timer 0 interrupt, and X0 is for IT0 interrupt or external interrupt 0. So this D0 bit is used for external interrupt 0, D1 bit is for timer 0, D2 bit is for time external interrupt 1, then D3 bit is for timer 1, then D4 bit is for serial interrupt, D5 and D6, these two bits are not used for 8051, and these two bits, and the D7 bit is enable all interrupt. Okay. Now keep in mind, if suppose here you have set this ES or serial communication interrupt, you have set the timer 0 interrupt, and you have disabled this ET1, TX1 and TX0. So only two interrupts are enabled. Just I am giving an example. So if only serial interrupt and timer 0 interrupt are enabled, but if EA0 bit is 0, then in that case, here what will happen? These, though serial interrupt and timer 0 interrupt, these two interrupts are enabled, still these interrupts will not get solved because enable all interrupt is disabled, or is enable all bit is disabled. So if this bit is 1, then and then only whatever the enabled interrupts are there, that will get served. Otherwise, the bits are, if it is 0, then all the interrupts are by default will get disabled. Okay, now we will move towards the interrupt priority. Already I have told you the priority. So highest priority is provided to the INT 0, then timer 0 interrupt, then external interrupt 1, that is INT 1, then timer 1 interrupt, and the least priority is provided to the serial interrupt. Now, what does it mean? If suppose during the execution, if suppose the interrupt has been generated at this timer 0 interrupt, and here the microcontroller is serving this interrupt, or in other words, we can say that during the execution of main program, if these two interrupts, external interrupt 0 and timer 0 interrupts are generated simultaneously, then to which interrupt will get served first? Okay, so here what will happen? The interrupt which is having the highest priority, that will get the first service, and after execution of that interrupt, the second interrupt will get generated. Okay, so here external interrupt 0 will get served first, and after that timer 0 interrupt will get served. Okay, so here depends upon the priority, the services are provided to the different interrupts. Now, to change the priority, here we have interrupt priority register. Okay. So this is called as IP register. So in this IP register, these three bits D7, D6, and D5, these are reserved bit. Okay. Then the D4 bit, it is for setting the priority of serial port. Okay. Then D3 is for setting the priority for timer 1. then D2 for external interrupt 1, then D1 for timer 0, and then D0 for external interrupt 0. So here, if suppose these bits are 1, then the highest priority is provided to that particular interrupts, and if these bits are 0, the least priority will get provided to that particular interrupt. Now, by default, here external interrupt 0 is having the highest priority. Okay, and serial port is having the least priority. Okay. Now, if suppose the programmer wants to change the priority, in such a case is that the timer 1 should have the highest priority as compared to the external interrupt 0 or timer 0. Then what the programmer will do? Programmer will set the priority for this timer one as 1 and external interrupt as 0. So what will happen? The timer one will get the highest priority, and after that the priority will be provided to the external interrupt 0. Okay. So in this way, the programmer can change the priority depends upon the requirement. But by default, by the microcontroller, highest priority is provided to the external interrupt 0. After that, the timer 0. After that, the external interrupt 1. Then for timer 1, and the least priority is provided to the serial port. Okay, so this is all about the basics of interrupt. Okay. Now,